My name is Carol Frost, and I'm an assistant professor here at the University of Alberta in the Department of Renewable Resources. That's a very interesting question. First of all, I'd like to talk about what is the difference between reclamation and restoration. Reclamation technically means the returning land following development or disturbance to an equivalent land capacity. And so what that means is pretty vague in terms of what we actually need to put back. But the way it has been interpreted in Canada historically is that we just need to make it so that plants can grow there. That's very different from restoration. Restoration is the process of returning an area to its natural state following disturbance. So reclamation projects in Canada have sometimes planted grass where there used to be forest, and that's considered reclamation of the forest, even though the grass species are non-native and grass isn't typically what's there. So now I think certainly but many people are thinking that restoration is what we should be doing, not reclamation. We should be aiming higher. We should be trying to restore areas to disturbed areas to the way that they naturally were. So that's the difference between reclamation and restoration. Now, how are all of these connected to the energy transition? Well, for production of any kind of energy, we have to disturb natural land. Whether that is drilling for fossil fuels, or whether that is constructing wind turbines, or whether it's constructing solar farms, we have to disturb the area in which we do that. And that's because we have to build the infrastructure. We have to build the wind turbines, we have to build the solar panel infrastructure and the underground cables. So we tend to do a lot of damage to the organisms that are there, to the plant community that's there. And so restoration does go hand in hand with development in natural areas. And just as there's lots of research on how to get energy in renewable ways and development of solar panels and that technology, there is also a lot of research going on at the moment about how to do restoration better. We're very good at restoration in forested systems because we've had rules in forestry that forest companies that harvest forests have to replant them, and they have to be good at that. So a lot of research has been put into that. But we've put much less research so far into how to do grassland restoration well. And grasslands are where we have most of our solar farms and most of our wind farms. And so the difficult thing about restoring grasslands is partly that in many parts of the world, seed for native species is not commercially available. That's a challenge in Canada and Alberta especially. For example, I'm involved in a research project that's studying revegetation for pollinators at the solar farm that we have in Edmonton. And the company doing the restoration originally proposed a list of 28 forb species. So that's native species that produce flowers that will support pollinators. That was in their plan. When they actually went out and tried to obtain the seed of these native species, they reduced the list to 8. So we have, in the Edmonton region, only 8 species of native flower that we can even obtain seed for. So that's one of our challenges in restoration for energy development projects in grassland regions is developing the commercial availability of more native species. The second challenge is once you have that seed, how do you actually get it to establish? Typically, when we seed native forbs, what grows is a lot of weeds because the seeds were in the seed bank or the weed seeds grow in, and those weeds, so non-native, quick-growing, invasive often, plant species just choke out the native seed that we've planted. When we try to seed native grasses, our solution to that problem is apply herbicide because it kills broadleaf, fast-growing weedy species and allows grasses to grow. But when we're trying to seed native forbs for pollinators, we can't use herbicide to control the weeds, so we have to think of other solutions. So there's a lot of research going into that at the moment too, and I have a student, I'm co-supervising a student who's working on that question. So some options are mowing can help, hand weeding, although that's extremely labor intensive, grazing by goats or sheep is one method. And Also, we can use methods to try to remove all the seeds in the seed bank, like solarization, cover the ground with plastic so that the soil heats up and all the weed seeds die basically before you seed native plants. So these are some of the challenges with restoration in the energy transition, but I would argue that it's extremely important because it disturbs so much land, and we don't really have any more land that we can sacrifice. Currently, only 25% of the land on the Earth's surface is in a state where it's natural enough, it's undisturbed enough by people that natural ecological and evolutionary processes can occur. So if we're going to use more of that land to develop renewable energy infrastructure, I would argue that we need to also be restoring that land so that it also can support biodiversity. So it's having two functions. It's producing renewable energy, but it's also supporting biodiversity. So that's why restoration and the energy transition should go hand in hand.